Alright, let's take a look at Chapter 5 test and see if we remember how to do any of these. Let's start with the first three. It says point U is the incenter. Well, we got to know something about the incenter. Here's the incenter right here. In order to find the incenter, what we do is we take the angle bisectors of all three vertices. So this angle right here is being bisected, so is this one, and so is this one down in here. They're all being bisected. That means that if it's being bisected, this little ray or line, whatever you want to call it, line segment, is bisecting this angle. This means this angle and this angle are equal. These two angles up here are equal to each other. These two angles down here are equal to each other. Alright, so that's going to help you out with a little bit here. Here's another thing. This point right here, the incenter, is equidistant from the three sides of the triangle. That means from, let's see, M to U is going to be equal from P to U and from B to U. So all three of these right here are equidistant. It also forms right angles because that's the distance from a point to a line segment is the perpendicular distance. Okay, so let's take a look at what we're trying to find. We're trying to find MU. MU is this line segment right here. So let's do this. Let's come over here and just put a number 1. There's really no work to show on this particular one because remember this incenter is equidistant from the three sides of the triangle. Now you can't see it very well right here, but you should be looking at your test. That length right there from U to P is 5. So that means from U to M is 5 and from U to B is 5. That means MU is equal to 5. So MU equals 5. That's as simple as that. No math involved at all. Just understanding where the incenter is actually located. Let's take a look at this. UGM. Let's figure out where UGM is. Here's UGM. That would be this angle right here. Again, no math really involved. You just have to understand about the incenter. Remember, this in order to find the incenter, we bisected all three of these vertices. So this angle, this big angle right here, is being bisected. So this angle right here, again, it's hard to see, but if you look at your test, you should be able to see it. It's 28 degrees. So if this is 28 degrees, then this angle right here is going to be 28 degrees because this big angle is being bisected, which means the two angles are equal to each other. So number 2. Alright, pretty simple. Angle UGM is also 28 degrees. So there's really no work to do. It's just a matter of understanding that to find the incenter, you bisect this angle. Alright, let's look at the next one. PHU. Wow, this is just as easy. Wow, I made these pretty simple, didn't I? And again, the math is not hard. That's not what I'm trying to test you on. It's just trying to test you on the understanding of where the incenter is located. So PHU is this angle right here. All right, so the same thing. These two angles are equal to each other because this angle is being bisected. So if this is 21 degrees, then this angle right here is 21 degrees as well. So angle PHU is 21 degrees. All right, pretty simple. That's incenter. On these particular problems, you didn't really have to do any work at all. All you had to do is just understand what the meaning of incenter actually is. Alright, let's go to the next one, which is circumcenter. Alright, let's look at the next one. Wow, I just figured out how to, I took this from my original test, and I copied and pasted it. I should have thought of that a long time ago. But anyway, now I'm doing it. So let's take a look. Circumcenter. How do you find the circumcenter? Well, point P, it says in the instructions, is the circumcenter of this triangle ABC. And so what does that mean? How did you find the circumcenter? What we did was this. We took the perpendicular bisector of the three sides of the triangle. So we took this side right here, BC, we found the midpoint, which is point T, and we made a perpendicular line to that midpoint. So it would go up and down like this. Then we took the midpoint of this side, and we did a perpendicular line to that midpoint. We did a midpoint of this side, which is point S. We did a perpendicular. They all meet. They're concurrent lines. They meet at the same point, and that would be the circumcenter. Now, what's true about the circumcenter? Now, it's definitely not equal distant to the three sides like the incenter was, but what it is this. It's equidistant from the three vertices. That means BP, AP, and CP are all equal to each other. So that's going to help us out with this. So the problems they ask you on this, a little bit different. They don't ask you for numbers. They just say what segment is congruent to these segments. So BR. So we want to find out what other segment is congruent to BR up here. So look, here's BR, this segment right here. Now remember what was true about this point. Remember, that was a midpoint. So If this is a midpoint, then BR and AR would equal each other if that was the midpoint. So there's your answer. That's all there is to it. So it's line segment AR. That's equal to BR. There's no other, we don't know that these sides are equal to this or anything like that. That's all we know. So that's all we can say. So AR is our answer. Let's take a look at number 5. BP. We want to find out what is congruent to BP. Well, let's find BP. Let's get rid of these little tick marks. Alright, so let's find BP. BP is this segment right here, from B to P. And we want to find out what else. Now, notice what it says. It says list any segment, or parentheses S, segments. Okay, so that means it could be one or could be more. So if there's more, we have to list them all. So let's take a look. Remember, this is the circumcenter. The circumcenter is equidistant from the 3 vertices. So P to B is going to equal PA and PC, or AP and CP, however you want to say it. So it's got to be both of those. So all 3 of those are equal to each other. So what's equal to BP? Well, PA and what else? PC. All right, so you have to have both of them. And of course, you could say AP or CP. It doesn't make any difference, but you got to have both of those. All right, let's go to the next one, which is centroid. All right, I got the triangle written down, or drawn it out here for 6, 7, and 8, and it says find the centroid. Well, we got to know something about the centroid. How did we find the centroid? Well, the way we found the centroid is to find the median of all 3. Should I say angles, or let's say? Well, we find the median. All 3 medians of the triangle. Let's just say it like that. Okay, I'm just trying to be correct here. How do you find the median? You start from a vertex and you go to the midpoint of the opposite side. That means that this and this are equal to each other. Then these 2 right here are equal to each other, and these 2 right here are equal to each other. So we know that. Now there's something else that we know. That point right there, the centroid, it's got a certain relationship to it. We've talked about this. Let's just talk about this one, JD right here. Remember, this is the shorter part right here. So when you go from the side, or from the midpoint to the centroid, that's the shorter side. That's going to be 1/2 of the longer side. Or you could look at it another way. You could say the longer side from the vertex to the centroid is twice as big as this. So let's just do a quick example before I actually do this problem right here. Let's say that that was 5. Well, if that was 5, remember this is twice as big. So the whole thing right there would be 10. So that's how we find the lengths of those 2 segments right here. You could look at it another way too. Watch. This right here, the 10, that's actually 2/3 of the whole entire segment. The whole entire segment would be 15. If I took 2/3 of 15, I would get 10. Since this is 2/3 of the whole thing, then this would be 1/3 of the whole thing. This is 1/3, this is 2/3. Altogether we get 3/3, or the whole entire line segment. There's a lot of ways you could look at it. The way I like to look at it is this, is that the shorter one is half of the longer one, or you could say the longer one is twice as big as the shorter one. So if they told you the whole thing was 15, let's say, let's get rid of this. Again, we're just doing a little bit of pre-teaching right here before we actually do the problem. So what if I knew that the whole thing, JD, was equal to, for some reason my pen's going smaller than it should, JD was equal to 15. Remember, the whole thing is 15. So remember, this is 1/3 of the whole thing. So all I got to do is take 15 divided by 3, take 1/3 of it, and I've got this right here. So 15 divided by 3 is 5. Once I got this, I just double it, and I get this. You could take 2/3 of 15 and get 10. I think it's a lot easier just to take 1/3 of 15, get 5, double it, and you've got that right there. Okay, so with all that said, let's get rid of some stuff. We're not using the 5 anymore, and we're not using the 10 anymore. Let's use the numbers that they actually give us. It says UK is 12, so they tell us that's 12. They tell you EM, this whole entire thing. Tell you what, instead of writing it on my triangle, it might be easier if I just wrote it right here. So EM, the whole entire thing is 21, and UD is 9. UD right here is 9. All right, let's see. We could figure out all the other segments right now if we wanted to, but let's just find out the ones we're looking for. So number 6, CU. We're trying to find CU. We'll find it. It's right here. Okay, well look, this is CU. Again, from the vertex to the centroid is the longer one. That's twice as big as this. So this is the shorter one. It's 12. So the longer one is twice as big as the shorter one. So if this is 12, CU is twice as big, so it's just 12 times 2, which is 24. So CU is 24. That's all there is to that. I knew the short one. I can find the long one just by doubling the short one. All right, let's look at 7. It's MU. Alright, let's come up here and look for MU. Now look, I don't know the longer one or the shorter one, but what do I know? I know the whole entire thing. I know the whole thing, EM, is 21. Well, remember earlier? How do you find, if you know the whole thing? I find the shorter one first, and that's exactly what we're solving for, is the shorter of the two sides. So what is it? The shorter side is 1/3, not a half. A lot of people think it's a half. It's not. It's a third. Okay, this is not a midpoint. All right, this is 1/3 of the way here. It's 2/3 of the way of this one. So this is 1/3. So I take 21 divided by 3, which is 7. So UM is 7, or MU, however you want to say it. All right, let's take a look at number 8, JD. So let's look at JD. We want to find the whole entire thing. All right, not just from here to here, even though we're going to find that in a second. I want to find the whole entire thing, JD. Well, what do I know? I know this side. UD is 9. Well, is that the shorter one or is it the longer one? Sometimes you can just look and tell, but from the vertex to the centroid is always the longest side. To the other side, right here, that to the midpoint, that's the shorter one. So this is the longer one, 9. This is the shorter one, JU. How much shorter? It's half of this. Well, half of 9 is 4.5. I'm not writing that very clear, but it's 4.5. But we're not trying to find the shorter. We're not trying to find JU. We're trying to find JD, the whole entire thing. So JD is the combination of the 9 and the 4.5. You add those up and you get 13.5 or 13.5. That's how you find the centroid. Okay, number 9, you'll be happy about this. On number 9, I think I even told a class earlier this week, I'm not really sure, but I'm not going to give you any of the coordinate geometry parts of this, so you don't have to worry about number 9. Alright, here we go. Put down both pictures for number 10 and 11, make it a little easier to see. Alright, let's look at number 10. It says, list the angles and the sides of each triangle in order from the smallest to the largest. Okay, so we want to find the angles and the sides. Well, I think on the, well anyway, you can see the sides are easy. What is it? It's 2, 5, and 6. So the sides would be RP, that would be the shortest one, PQ, this isn't the hard part at all, and then RQ. Alright, so that's from the smallest to the longest. That's the sides. What about the angles? Okay, that's the thing we want to think about. Well, we have a theorem that says that the angle opposite the smallest side is going to be the smallest angle. So watch. Angle Q is opposite 2, so that's the smallest angle. So angle Q is the smallest one. The next bigger side is 5, so look at the angle opposite that. That would be angle R. So angle R is the next one up. So that would be angle R. Alright, and then the 6 is opposite the biggest angle. I'll just put 3 arcs right there. Okay, and so angle P is the largest. That's all there is to it. So those are the sides in order from smallest to largest. Here's the angles in order from smallest to largest. Let's look at 11. Now, we have to figure out what this angle is right here before we can figure out what the order of the angles are. So you know it's 180 degrees, so let's do this. Let's add up 98 and 43. Okay, that's 11, that's 13, that's 14, that's 141, and we can figure out this angle by just taking 180 minus 141. Let's see, that's a 9 and that's a 3, so that would be 39 degrees. So we had to do that first. Now, to put the angles in order from smallest to largest is easy because they're right in front of you. So this is the smallest one, so angle S is the smallest one. The next one would be angle U, and the next one would be angle T. All right, the one that we really are concentrating on are the sides. So let's do the sides. Let's see, the smallest angle is 39 degrees. So look opposite the smallest angle. Opposite the smallest angle is this side right here, UT or TU. We'll call it TU. Okay, so that's the smallest side because it's opposite the smallest angle. Here's the next bigger angle, okay, the one that's in the middle, if you want to call it that. So you look at the side opposite that angle, which is TS. So TS is the next one. right? Now basically it's just a matter of elimination on the next one. But look, this is 98 degrees. Opposite the largest angle is the largest side, so US is the largest side. Those are pretty simple. Alright, this is pretty easy. State the assumptions. I think everybody likes these. State the assumption you would make to start an indirect proof. So remember, we always assume on the indirect proof, we always assume that the opposite of what we're trying to prove. This is what we're trying to prove, so what are we going to assume? We're going to assume that angle ABC, now this says it's less than angle CBA, but I want to say it's not less than. But I don't say it's not less than. If it's not less than, it has to be greater than or equal to. Don't forget the or equal to. So angle ABC is greater than or equal to angle CBA. All right, number 13, pretty much the same kind of deal. It says triangle DEF is congruent to triangle RST. That's what we're trying to prove. So in an indirect proof, our assumption is going to be the opposite of what we're trying to prove. So we would say that triangle DEF is not congruent to. So here's congruent, there's not congruent to triangle RST. Really simple. Okay, let's just go ahead and do 14. It says write an indirect proof of the following thing. So the first thing we're going to do, here's our picture. We're given that angle D and angle F are not equal to each other. So watch. I'll keep this small right here. I won't redraw it, but I'll make one real small arc and one bigger arc. So we'll just say that they're not equal to each other. I don't really know that that's smaller than this, but we know that they're unequal to each other. So I'll make one small and one big. Or we can make one with one arc and one with two arcs. That might be better, just to show that they're not equal to each other. Well, we want to prove that line DE, or line segment DE and EF are not equal to each other. So what do we assume? So we assume the opposite. We assume that DE, line segment DE, is congruent to EF. Alright? So we assume that they are congruent to each other. So let's put some congruent marks. Alright, so if these two sides, if DE or ED and EF are congruent to each other, what does that mean? Well, if you have a triangle and you got two equal sides, that means the angles opposite those two equal sides must be equal. So if we assume that DE equals DF, that means that angle D is going to equal angle F. Okay? But what we assumed and there's a contradiction. I'll put a little contradiction symbol there. Okay, that's our contradiction. But what we assumed about DE being congruent to EF is false. Therefore, and there's probably more you could write to this, but this is good enough. You could say that therefore angle D is not equal or congruent to angle F. All right? That's good enough for right there. If you put that down, that's perfectly fine. All right, let's go on to the next one. Is it possible to form a triangle with the given lengths? So I've got 3, 4, and 6. There's just like a little trick to this. I'm not going to go through the whole explanation of it on how we came up with this, but you should be able to do this pretty easy. Remember what we do? We always take the two smaller ones, and the two smaller ones have to be greater than the largest side. Okay, take the two smaller sides, 3 and 4, add them together. Take the sum of the two smaller ones, and it has to be greater than the largest side. So that's 7. Is 7 greater than 6? Sure it is. So it says, is it possible to form a triangle with those lengths? Yes, it is. So we just say yes. All right, and there's my work. All right. Okay, number 16, same kind of deal. We'll just write down the 3 sides. We want to see if those 3 sides can form a triangle. Well, what do? You take the 2 smaller ones. That would be 6 and 9. So you add 6 and 9, and it has to be greater than the third side, or the largest side. Take the 2 smaller ones. The sum of the 2 smaller ones has to be greater than the largest side. Well, 6 and 9 is 15. Is 15 greater than 15? No, it's not. So, no. You cannot have a triangle with those 3 lengths, 6, 9, and 15. All right, let's take a look at 17. 17 is very much related to 15 and 16, so we'll do that. And let's see what those sides are, 12 and 18. All right, so I've got 12 and 18. And it says, find the range for the measure of the third side. Remember, you got three sides of a triangle. If these are two of my sides, I want to find out what is the possibilities for my third side. Remember, it can't be any length whatsoever. It's got to be in a certain range. And again, we've talked about it. You can go back and look at the YouTube video if you like, but here's an easy way to do it. You just subtract the two numbers. So 18 minus 12 is 6, and then you add the two numbers. 12 and 18 is 30. So that's your range between 6 and 30. How do we write it though? You can use any letter. I'll use x. That means x has to be between 6 and 30. Notice x is greater than 6, and x is less than 30, and that's how we write our answer. All right, let's move this up, and we'll look at the last three. All right, we're almost done this chapter. Let's take a look. It says compare the given measures. When it says to compare, you tell which one is bigger, which one is smaller. So it's going to be AB is less than BK or AB is greater than BK. Let's take a look. I made it a little bit bigger here so we can see it. So AB, and let's just mark it, and BK. I'll just put two things. I just want to find out, is this bigger than this, or is this one bigger than this? So how do we find out? Well, without getting too technical, you take a look at the two triangles and you compare the measures of the angles. Okay, find the angles first because I want to look opposite those angles to see which one is opposite the bigger angles. So with that said, look what we have. We got 30 and 40, which is 70. So I can find this angle right here. So 180 minus 70 is 110. Okay, so that angle right there is 110. How do you find this one right here? Well, that would just be 70. All right, so now we look to see opposite these angles. See, this side right here is opposite 110. This side right here is opposite 70. And so the one opposite the bigger angle, the side, I should say, opposite the bigger angle is larger than the side opposite the smaller angle. So AB is larger than BK. So that's how we write it. All right, AB is greater than BK. That's all there is to that. Let's go to this one. We're trying to find these angles right here. Let's see. I'm sorry. ST and SR. That's what we're trying to see. ST and SR. So we'll put one tick mark for this. We'll put 2 for this. So what am I trying to do? I'm trying to see opposite these angles, which one is bigger. Well, look, I don't even have to do any math or anything with this. I don't know that these are definitely not equal to each other because look at what the values are. This is x minus 3 and this is x plus 3. Well, if you take any number, okay, any number, and you take 3 away from it, and you take that same exact number and then you add a 3, which one's going to be bigger? Well, the one where you added 3 is always going to be bigger than when you took 3 away from that same number. So this angle right here is going to be the bigger angle than this little angle right here. So look, opposite is ST, so ST is going to be greater than this one, which is RS or SR, however you want to say it. They said SR. So let's keep it in that same order. Let's write ST is what? ST is the bigger one. Now look, you could have just kind of looked at this and said, oh yeah, I can just tell by looking at it that this side is bigger than this side. But you don't always want to go by that because you never know if they might have drawn it not to scale just to kind of trick you up a little bit. So be careful with that. I could very easily have made this x plus 3 and this x minus 3 just to trick you up a little bit, just to make sure that you're following the rules, even though it might not look like it. All right, so what if this was x plus 3? Then this side would be bigger than this. And you're thinking, well, wait a minute, that doesn't look bigger than this. But we don't go by just the looks, do we? We've talked about that almost since day one. We don't just go by the looks. You've got to go by the information, go by the numbers. Anyway, I'm going by the numbers. X plus 3 is bigger than x minus 3, so ST has to be greater than RS or SR. Since they call it SR, we'll call it SR. And that's your answer right there. All right, let's go to this last one right here. We want to take angle CDF. So CDF, that would be this angle right there. And angle EDF, this one right here. And I'll put 2 arcs, and I just want to compare them. I want to see which one's bigger than the other one. So let's take a look. Look at this angle right here, CDF. What's it opposite? It's opposite a side of 12. Look at this other angle that we're looking for, EDF. What's it opposite? It's opposite a side of 13. So which one's bigger? Well, the angle that's opposite the bigger side is going to be bigger than the angle opposite the smaller side. So this one EDF is going to be larger. Or I could say, since it's in this order, CDF, watch, CDF, that's first, okay? So CDF is what to this one right here? It's smaller because it's opposite 12 and this one's opposite 13. This one's smaller. Why did I put equals right there? I don't know. Okay, because it's not equal. It's what? It's less than. So angle CDF is less than angle EDF. It's supposed to be an angle symbol. EDF. All right? That's all there is to it. That is chapter 5. I hope that helps. Now on to chapter 6.